Characteristics of sound waves. As sound waves propagate through a medium, they give rise to a chain of compressions and rarefactions. Compressions are the places of higher density, and rarefactions are the places of lower density in the medium. The particles of the medium oscillate about their central or mean positions in a direction parallel to the direction of propagation of the wave. Such waves are called longitudinal waves. On the other hand, in the waves created by dropping a stone in still water, the particles of water oscillate up and down. These oscillations are perpendicular to the direction of propagation of the wave. Such waves are called transverse waves. Come, let us understand more about sound waves. Here, 3 figures are shown. Let us observe them. At any moment during the propagation of a sound wave, we find alternate bands of compression and rarefaction of the medium, that is, bands of greater and lesser density. First figure shows the changes in density, while second figure shows the changes in pressure. The changes in density or pressure in a sound wave are shown in the form of a graph in the third figure. The distance between 2 consecutive compressions or 2 consecutive rarefactions is called wavelength of sound waves. It is indicated by the Greek letter lambda. The change of density from maximum to minimum value and again to maximum value makes one oscillation. The number of oscillations per unit time is the frequency of wave, and it is indicated by nu. The amplitude, which is the maximum value of pressure or density, is indicated by letter A. The time taken for one oscillation of pressure or density at a point in the medium is called the time period and is indicated by T. The value of frequency determines the pitch of the sound, that is, how much high or low is the sound, while the value of the amplitude determines its strength or loudness. After studying about the different characteristics of sound, it's time to answer some questions. Do you know how are the frequency of notes sa, re, ga, ma, pa, dha, ni related to each other? The frequency of standard tuning of sa is 440 Hz. The frequency of re is about 494 Hz. The frequency of ga is about 554 Hz. The frequency of ma is about 587 Hz. The frequency of pa is about 659 Hz. The frequency of da is about 740 Hz. The frequency of ni is about 831 Hz. And the frequency of octave sa, that is tar sa, is 880 Hz. The frequency ratio of re to sa is about 1.12. The ratio of ga to re is about 1.12. And the ratio of octave sa to sa is equal to 2. Now the next question is, what is the main difference between the frequencies of the voice of a man and that of a woman? The voice of a woman has a higher pitch. That means it has higher frequency than that of a man. Let us now proceed further.